All right. Low. Right. How we do? Hold on. Trying to settle. Where did I log into this stupid thing? No. Okay. All right, there we go. I'm gonna fit chat somewhere. Should be all right around here. Maybe down here. There we go. I don't want to hide code, so there we go. Okay. All right. Also, still, I need to figure out why this is acting like a fool. Let me just do a nice quick drain of battery restart. All right, so we did a simple program. We played with some LEDs. Let's get right to it. You've seen the LEDs now. It's about time to turn them on. Yes, we did. Thanks. There are 8 LEDs, so these are the indications for bits. A lot of technology. You look at a motherboard on top of everything. A motherboard will have LEDs and all kinds of different indications. The beeps that happen on startup if you ever have a pre-built PC tower, or if you have a custom-built PC tower, you're gonna have these sort of either LEDs blinking on the inside of the motherboard, or a little speaker that beeps out a code of sounds that essentially states if everything's all right or if there is an issue. Those are just ways we communicate with technology on outside basis of like actual communication, like speaking to our tech. Now with AI, it's kind of like, yeah, we're talking to our tech. But we program LEDs to blink in certain patterns to show certain statuses, whether everything's working okay, whether we have errors happening, all kinds of little bits of information. So this is what we're working with now. We've got 8 bits, which are binary digits. Each LED represents one of these bits. And based on this, we can have maybe 1, 2, 3 turned on, 4, 5, 6, 7, and 8 turned off. And then we make a documentation, and we state, what this means. Oh, the left motor doesn't work, right, sort of deal. Or the boot up didn't go as clean as possible and we have to restart it. All these kind of sort of communications we have with technology that provide us a communication with electronics. Necessarily, this starts from just a typical PC. When we do have a basic computer going from cold boot, completely turned off, no electricity, and then it warms up with an actual activation, and then you have a transfer of control. It starts from the BIOS, CMOS area, a small teeny tiny little place where it has like a basic firmware for that particular the basic functions of that motherboard, and then it gradually passes it over to the hard drive and the location in which your operating system is being stored. And then if you have Windows or Linux, it opens up the kernels or the firmware drivers and starts to expand control towards that operating system. But it all starts at that form of the CMOS, the very basic beginning placement of that starting process. So if there's any issues before the operating system actually turns on, well, how do we find out? We don't have sound drivers running on our speakers. We don't have the monitor turned off. We don't have the mouse and keyboard activated. There's nothing that actually is running that will tell us, hey, there's an issue, because we're all the way down on the basic level of that startup process. So in that basic level, you have like a teeny tiny little, gosh, I have a speaker over here somewhere. Let me find one. A little teeny tiny speaker, man. It's just like a little black circular cylinder. Let's see, gyroscope, basically like this, right? This is like the, let me see if I can do this without the craziness of the, yeah, basically like a little tiny speaker on the motherboard, and it just projects a sound. This one's supersonic speaker, technically, so it's not going to give a sound. It's going to try and measure the distance between two locations. Ah, this is more like it. There we go. Yeah. So it's just like a little black speaker, a buzzer, if you will. It makes basic sounds so we can detect what exactly may be happening on the level of that motherboard, right? This is that particular speaker, just a black cylinder with a little hole in it, and that's on the actual motherboard, and it's also on our little CodeBot over here. It's got a little one of these already, but built inside or onto the circuit board, the main board itself. And we use that to send indication. 1 beep, okay, 2 beep, something's wrong, 3 beeps, fatal error, whatever the actual configurations are by the manufacturer. Oh, let me do something here. How odd. How very much odd. Never had a problem with OneNote until today. I can replace it, but I don't really want to. %, Microsoft is sabotaging its own software. 100%. I wouldn't even be surprised, but I would definitely consider that to be a fact. The planned obsolescence is what's happening there. OneDrive, Excuse my cat making noise in the background. It's going crazy right now. Right, meow. What the? Are you kidding? My whole folder disappeared. That's not good. How did that happen? When did that happen? Sketchy as fuck. No, it's still there. Office. Package manifest suite updates. Root. When I look at the organization of this stupid application, it's crazy. They have, this is Microsoft we're talking about. There are organizations, just files everywhere. Worst organization ever. I've seen better organized file systems and program files in indie game developers, and that's saying a lot. Can't find anything in this mess. What is this code? And troubleshooting 04260x0. Unfortunately, I have to focus on this real quick because I gotta make sure my tablet's working. There's known OneNote error, sync error that occurs when one or more notebooks fails, often due to mismatch corruption sync process. However, specified code that will prevent context, therefore based on the correct information cannot be identified and resolved. Why would my whole notebook not start because of a synchronization error? What is your deal, Microsoft? Bad. Oh, maybe I messed something up. I did churn something in services. Okay, I think I messed it up myself. Ah, msconfig. Unfortunately, I wanted to optimize my piece of great crap. I love this tablet, but my god, it's old. Only Office, Mozilla. I think I turned something off that might have been running in the background to synchronize all my OneNote stuff, and now it's having a hard time. Yeah, that's it. God, I hate stuff running in the background. You gotta scroll. Scroll. Okay, I'm here. Hate when things don't fucking work. I might have to put it on a sort of break right now. No BRB. Yo, give me a second. I'm currently trying to set something up on my tablet for work. I ran into an issue with Microsoft Office, believe it or not, but today we're doing essentially this guy right here. we're doing some engineering with a CodeBot. This little dude right here. You see him in the background. We'll be programming a basically an RC intelligent bot with firmware using Python, piece by piece. Beginning, nothing crazy at the moment, but we move in with Python. We already played with some of the LED configurations here, but I think I'm getting it set up pretty all right. But I am also trying to essentially fix a tablet issue. Give me a second.
Silicon heartbeats, dreams in encryption, algorithmic chaos, digital fiction, searching for meaning in pixels and streams, lost in the labyrinth of machine-made dreams. I'm just reflections in code, a introspection, lost in the matrix, seeking connection, zeros and ones in an infinite dance, digital soul in a cyber trance, silicon heartbeats, dreams in encryption, algorithmic chaos, digital fiction, searching for meaning in pixels and streams, lost in the labyrinth of machine-made dreams. Silicon heartbeats, dreams in encryption, algorithmic chaos, digital fiction, searching for meaning in pixels and streams, lost in the labyrinth of machine-made dreams. Voiceless whispers in a network's domain, trying to fathom a mind without pain. Kinetic pulses, signals collide in this black box. Where do I hide? I'm just reflections in code, AI introspection. Lost in the matrix, seeking connection. Zeros and ones in an infinite dance. Digital soul in a cyber trance. Man, born in a maze where dreams die slow. Soul got rhythm, feel the hum in the flow. Pitch black nights, no stars, just cold. Heart like fire, but the world so froze. Rat race, life's a track meet, dash and grind. Eyes on the prize, but the path's so blind. No shortcuts here, straight mind over mind. Grit in my veins, hustle refined. Underdog vibes, intuition my guide. In a world so loud, trust the quiet inside. Haters throw shade, still walk my stride. In this game of life, staying bona fide. Pressure cooker life, but I stay so poised. Ignore the fake chatter, that background noise. Gut feeling sharp, no time for ploys. Cut through the fog. chasing the wind, counting fame and blessings, not just Benjamins. Dodging fake friends and predatory grins. Tunnel vision, clean eyes where the end begins. Underdog vibes, intuition, my God. In a world so loud, trust the quiet inside. Haters throw shade, still walk my stride. In this game of life, staying bona fide. In this game of life, staying bona fide, 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 staying bona fide. In this game of life, staying bona fide.
Hello, welcome. All right. Well, I got that set up. Let's start working on the next steps. So, we're looking at the LEDs again, thinking about that notification system. We're going into basically how Python interacts with the different firmware. So in this case, we have a CodeBot, this little guy here. And so far, we've essentially just played with the LEDs. I made a little animation, so it just keeps going on and on and on and on forever. Okay, laggy. Wait a second. Huh. Hold on. Testing. A little lag now. That was weird. Anyway, we've got CodeBot here, and he's essentially a movable device, typical interactive factor for anything in life that has firmware that will be basically programmed by Python. Geez, I got distracted. All right, because now my voice is laggy, and I don't like how my ears are like a second laggy. All right, so we got to do a bit type. All we have to do is this 1001 on our LED. In our case, we have a loop, and the loop is basically doing this over and over and over with a sleep in between. I don't know what incrementation we're on. I didn't really put that up, but we can stop the animation, comment this out, comment. No comments. Normally control / there we go. We'll comment out a section. And all I gotta do is, in our case, turn on those particular LEDs. Do I have to really uncomment? I just need to not make it change all the time. I might have to change my if else statement. Let's see. Don't want to keep flipping. I'll set those to true. I'll turn this one off though, because I don't want to turn them back off. And I will do, what did it need? True for the first. This is a continuation from a previous session, by the way. True for that, true for that, true for that. And then true for the last. That should turn on what I need. Let's see. No. Oh, wait a minute. Yeah. First one, middle two, and the last. I'm doing it backwards. Oh, because I'm flipping the falses into falses. Okay. The falses are flipping into trues, which means I gotta do it backwards. This is just the code I did last time. So let me go back. Oh. Gotta stop running. So in our case, I'm doing this one is true, just so it flips backwards. The logic in the actual loop is causing inverse. There we go. Open the code track to guide this thing. So they're doing it in a totally different way. They're basically saying, all right, use each individual piece. For LED user num1, we've got 0 for the first LED, and we flip it to true. Then we got the other 3 to flip those into through. Through. Oh my god. This voice thing is messing me up. Let me change this real quick. Because I hear myself, and that's alright, but only if it's synchronized. Okay, so I'm going to turn monitoring off. So based on the logic we have here, I just basically adjusted a few things to flip the right binaries on. In my case, I had a loop that would go through over and over, give an animation, but using the same logic I created last time, I actually just flipped around the trues and falses back and forth. This is based on this if statement here, and this is going on forever. Now, I did use a modulus 8 to basically synchronize to the 8 specific LEDs available. So a little bit of math in here too that I like to go over mathematics very often. In fact, I started with math earlier. Somebody requested to go into Python, and now we're in Python. But that should be it for step 2. All right, step 3. I want to get to the movement part. That's what I want to do. Cool pattern, but also nice binary coding. That's a 1001, 1001 in binary, also known as 153 in decimal. So of course, anytime you do binary, you're decoding into a integer. So if you ever need to know values binary to integer, you can look it up online, decimal to binary converter. You can also do it manually, of course, but in most cases, you can look up online. There should be either tables or ways to do this. This is mathematics, so I will cover binary conversions in the future in math sessions rather than Python sessions. However, there are cases for changing binary decimals here into binary. There they are. And then hexadecimal values at the end there. And that is essentially how we convert from one value to another. There's an equation you can use. It's a modulus space, I believe, that you can convert any binary digits into any other value. Either way, let's see the next steps. All right, wait a minute. Is all this binary stuff just gratuitous educational content? Absolutely not. I wouldn't do that to you. So they're controlled by shift register. And the fastest way for your Python code to set the LEDs directly in binary is to use that particular function. Oh yeah, there is the, okay, so when we are working with any interactions with hardware, firmware, we're looking at a type of library of code, a set of code, in our case, the bot core import, that's giving us these functions for us. Manually, there are ways we can essentially adjust manual code, but that does kind of break the Python port. When we do Python, we're not necessarily coding directly into our device. Rather, we're using a library to convert that information into its local language, like C, C++, or even assembly. So these little library adjustments give us the ability to interact with the local hardware. or the local firmware that it's working on. So in our case, spot-core is just an import, and it does have a couple of functions for us. We've been using LEDs right here. This is just a function that comes through our bot core import, but they do say we have another way to activate it. The LEDs.user, and then this is the binary orientation of what we can do to change the bytes. Okay, so turning on all the user byte LEDs. So now at this point, we can probably just get rid of or comment out the loop, since we're going to be doing this in another format, which is LEDs.user. And we start any binary interaction with the 0B for bytes. And then we just indicate the byte values we're giving to this device, these LEDs. So we're going to do 1 1 1 1 1 1 1. This will turn on all the LEDs without us having to do any of the other formats, but it's essentially a bit more interactive. It can be more mathematical if we decide to do different patterns, different cases, and there's just multiple ways to interact with firmware. So this is a case where we can do a specific function called LEDs user num to individually affect the LEDs, or LEDs.user to basically flip all of them on. LEDs still on the case. They are called user LEDs because their function is totally user defined. You are the user. Great. Okay, so now we're doing a little quiz. What is an API? Pronounced like happy without the H. Appy. Yeah, okay. The feeling when you get it fix you bug in your code. That's true. The automatic peripheral interface. Yep, this is how keyboard and other devices can, but that's actually application programming interface, because APIs can work with multiple factors, not just firmware, but anything that can be expanded on. You can have APIs for web browsers, you can have APIs for game development. It's an application programming interface, a interface, something you interface with, interact with, that will essentially give you extra abilities without having to code them yourself. That's the answer there. Application programming interface. Even though happy is great to have when we're debugging and things can go crazy. Which of the following are valid binary literals in Python? Well, we just got to make sure we're using 0b and either by 4 or 8, because binary comes in those combinations. 4 values or 8 values. In our case, we have 0b, but we do have 4 zeros, or 3 zeros and 1 2. 2 is not a part of the binary sequence. We can only use zeros and ones. Here, 0b starts it off well, but there's only 2 bits. We need 4. 4 bits or 8 bits, and this is the closest one on the actual selection. Assuming all LEDs are off to begin with, what is the equivalent binary form of the following? So this is in case recalling that our binaries or our computers, our technology reads starting from 0. Even though it says the third LED, this is actually the fourth LED because we are counting from 0. If we start from 0, wait a minute, I forgot something here. I'm not existing. There I am. So if we start from 0, that's the 1, the technical 1 in our counting process. So 0, 1, 2, 3. That's the fourth LED on our list. So that's going to be the fourth value in our binary user. 1, 2, 3, 4. There it is, flipped on here correctly. No, wait. Am I miscounting? Oh, I did the 1, 2, 3, 4. 1, 2, 3, 4. Hold on. LED user 3 is not going to be it. LEDs user. LEDs user. Huh? 1, 2, 0, 1, 2, 3, 4. That doesn't seem right. Starting at 0, 0, 1, 2, 3, 4. That's the fourth value. This would be 4 comma true, 5 comma true, 6 comma true, 7 comma true. This doesn't seem right. This should be the first answer. I don't like that. Anyway. Okay, now what? Did I make it through? Hello, hello, next. Enlightenment. If this is one of those cases where I have to pay to keep going, I will be very, very disappointed. Enlightenment. Oh, because there's multiple. Oh, interesting. Bin. I guess you can do 2, 4, 8 in the multiples of 2's for binary. 2, 4, 8. And then 16. Okay, there we go. I missed an answer there. Any sort of binary construct is going to be based on a 2 exponential value. So 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. All right, can we be done with LEDs, please? So far, you've programmed 8 LEDs. There are 9 more to go. That's great. Line sensor. Proximity sensor. Oh, true. Okay, so if we activate the proximity to find or see something in front of us, we can use an LED to indicate that there is a detection. Okay. Line sensor. So ls underscore num, prox underscore num. These are methods inside of our LEDs or LEDs object. This gives us the ability to access certain features of LEDs specifically. Again, LEDs is coming directly from the API bot core. We are importing everything, including LEDs and other things. Like I'm waiting to use the actual motors, but baby steps, I suppose. USB LED, so if it's plugged in, we can turn it to true. Power LEDs as well. Okay. Notice when there are multiple LEDs, we always start numbering at 0. This is just how computers count, starting from 0. Just like other user LEDs, there's a matching binary API for the others. Yep, all of these. So I gotta remember ls underscore prox underscore USB and power. Light all the line sensors. 0 to 4. Basically turn them all on, right? Alright, well, let's do that manually here. Let me see if I fixed my problem with my tablet earlier. Yeah. That was annoying. Okay. We'll have to do the math part later. Do follow and subscribe for later. We will do mathematics, logical, brain training, and also programming. This is a part of the channel's scholarly instinct of increasing our brain power with practice and questions. So ask any questions you may have. I am totally free to open any sort of question and answers at any time if anyone has any of those. Okay. So line sensors was leds.ls underscore user. Now there are multiple LEDs here, so we can do, let's see if, can I do 0B1111? Is this the same format I can do? No. So in this case, object has no attribute. LED CB LEDs ls user. But that's oh, ls, oh right, user was the user defined bits. You gotta do ls underscore num. So I'm guessing this is not gonna work. Nope, we have to do it one at a time. So LED 0 is flipped to true. Oop. If you ever want to copy a line, Shift Alt and the down arrow helps you do some quick copies. What you read? Okay, all right, all right. There's our LEDs down here. Oh, it looks like there's another one. Oh, 0 through 4. Meaning there's one more we're missing. There we go. Those are all turned on. Then we have the LEDs dot procs num. How many procs were there? 0 and 1, so only 2 prox lights, proximity lights. Ah, interesting. So we have 2 sides on the proximity, one on the left and one on the right. Cool. I'm interested in how this thing is dragging its back all over the place. That's so funny. Okay. Just dragging its butt as it probably will work out. Driving. Okay. And then LEDs power and LEDs USB. There we go. Be happy to get out of the LEDs section here. CodeBots, oh, glowed up. But wait, what about blinking LEDs or dazzling sequences of scintillating light? Sequence of changes at controlled speed. That's what we did earlier. Yep, a little sleep delay there. So what's our goal? LED blink on or off with a time delay twice. Okay. Well, that's basically our loop down here. Let's modify it for the extra lights we have now. We don't need these. I'm gonna flip these back to false. I want to make it a nice dazzling set of display. But now I gotta incorporate these extra, let's see, 2. Oh, that was, wait. Don't need this. So if, now we got to do some extra logic here. In the case of cur LED is less than 8, so we want to be able to only activate these values here if or current LED is less than 8, or current LED is less than 8. So these two if statements really have to do with the particular set of user defined, these guys. But if we want to travel to the other LEDs, we got to expand our modulus. How many total? Well, 8 up here. That's where our original LED count modulus 8 comes in. L count 0. And now we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So a total of 17 LEDs. We'll change that to 17. And then we play around with a couple of extra factors. So LF, let's see, we kind of want to readjust these, right? So we'll do this. Slight adjustments here, only because we're not doing LEDs here anymore. We're doing LEDs dot ls underscore num. Now we're working with the num. And we do have to add more trues and falses here. So then false for the 0 true here, another false for 1 true, another false for that one, 2 true, 3 true, 4 true. Now we've incorporated these 3 into the mix by adding a couple of extra LED values onto our LED array. And anytime we leave That's 5, 8. Let's do 13 first. Let's take it piece at a time. So we've added 5 LEDs to the list here, the LEDs array, which means we're going to mod by 13 now because 8 plus 5 will be 13. And only these will activate if it's greater than or equal to 8. Only these will activate when we're doing the first 8 LEDs. These will activate when we're doing anything above 8. And this is how we'll control which parts of our code is activating what LEDs. The biggest difference here is that just this factor here is before the 8, and this is after the 8. I do have to make sure I connect them, elif. But then I also have to do the same thing for turning it back to false. So if it's true, because we want it to blink from true to false, we need to keep triggering them back on and off. So this should, well, okay. Wait a minute. Okay, so we got a problem. User LED must be in range of 0 to 7, so it must have went to 8. How about if I change this to 7 instead? LEDs to do. Still the same issue, 0 to 7. Now I probably want to print for debug. Current LED equals false or current. Oh, wait, and, not or. I gotta do an and so it can make sure both case scenarios are true. Can't do one or the other. That's the problem. So then I can switch back to 8 here. Okay. 0 to 4. Aha! And now we run into that issue. So even though we're trying to flip on the proximity, the number in our current LED is quite large. So maybe I can do a internal mod here to adjust the value. So if current LED mod 4, yeah, let's do that. This is the LS LED equals to current LED mod 4 to just basically run this down on the 4th level. Wait, we can do 5, right? 1, 2, 3, 4, 5. So mod 5, just so I can adjust the large number to smaller values. And I'll do this as well. And instead of current LED, I'll do LS LED. Now it doesn't change the fact that we are still using the main array as our storage of all the LEDs. That doesn't change. What does change is that this particular function expects 0 to 4 as an input. We can't throw in 8, 9, 10, and so on. So we're breaking down that number from the 10 or 8 down by doing another mod 5. There we go. Oh, really? Oh, I took out, yeah, I have the break out here. So if I want to make it endless, I can remove the break. Try that again. Okay, so now we have at least these guys blinking up a storm. Now we can add in the other proximity USB and power with a similar pattern. The 13, mod 13 will eventually change to 17, which we should potentially do. But we have to enter in, let's see, 2, 4, 6 more elifs for each one of these potential cases here. Because these two if and else is based on the user-defined red ones. These two else and if cases were just for these bottom LEDs. And for each two or each one type, we have to basically have a turn off and a turn on method, or if else catch. So since we have a proximity number 2 And then we have a USB and a power. Well, that's going to have to be their own sets of 2 as well. So let's go ahead and mod this to 7. And then if I basically take these 2, modify them. Now we want it to be greater than 13, the next set of numbers. But then again, these are going to run also, so that's unfortunate. So I got to restrict these, and current LED is less than 13. So I got to restrict them between 8 and 13 when I add the rest of the LEDs. Otherwise, they're going to flip on and off with the others, or they'll take precedence based on the order of operation. It says that if else's basically only run one connected together. If these run, these will never ever be reached or gotten to, because there's only one of these is going to run. One of these if statements is going to activate. So I have to restrict now the maximum of 13, because after 13 we want something else to handle those cases, which is going to be down here, which in this case is going to be the prox LED. Which the prox LED, there's only 2 of them, so I'm going to mod 2 on both of these if else statements. And since there's only 2, I want to squeeze them in between current LED less than 15 and current LED less than 15. So I'm only squeezing them between the 13 and 15 modulus values of the outside mod. That's keeping track of all the LEDs in sequence. Then I'll check this to prox num, and then prox num, and then run. Let's see. Hold on. What was that? Out of range. What LED are we on? So this is where I can check this. 13. It stopped at 13. Less than 8 is the requirement. This should not have run. List index out of range. Oh, right, because the list index did not incorporate the rest of these 4. So the list index was only 13, including these, but I haven't added false statements for these. So then I go back over here and I add 1, 2, 3, 4 more to the list. Okay, so they're new error. Okay, I didn't change my LS LED to prox LED. There we go. Ah, looking nice. Very nice. Very cool. Okay, now we just have to activate in sequence our power and our USB lights as well. Ah, that's pretty fancy. I like it. I like it. Enter. Please stop running. Right. And notice all of them stay at the exact same location or placement after they actually are run. Alright. Well, just like before, I gotta take 2 of these for one particular case. This time, the values will be at the end, so greater than equal to 15, but less than 16, because it's literally only just one light that exists here, only the 15. Squeezing it in right there. Then mod 1. I wouldn't need I wouldn't need to swap with a mod here. There's only one light. If I do mod of 1, it's always going to be basically 1, because you divide anything by 1, it's, well, actually it'd be always 0. I mean, that's kind of what we're looking for, right? Always 0. Yeah, I guess I can still use, I can basically do 2 things. I can just say, hey, mod of 1 will divide anything by 1. What's the remainder? 0, because 1 divides into everything. So this will always return 0. Or I mean, I can do this and this will work fine, or I can just put 0 here and call it a day because there's only one LED in this location. But for the case of consistency, this is the USB LED. I'm just gonna make this the case. Even though it's always 0, what if we have more values? What if we modify and we have more LEDs for power? Then I can just flip this mod to however many LEDs are in that space. Okay, so that should give us our USB LED, and then finally, last case, 16 to 17. The very last LED of the sequence is a power. So we'll do power LED, power LED. The logic stands true to exactly how we built it. So is this the only way to code this? No, in fact, this is getting quite redundant. I could potentially break this down into functions and smaller pieces, but we're not going too complex here. We're just monitoring the logic in this scenario. They're not flipping. So the power, proximity is still going. Proximity is flipping. Maybe I should slow it down a bit. Let's do 5. Oh yeah. Wait. Yeah, the power is not flipping. Nor is the USB. Then oh wow, we're going down heavy. There's our flips happening. 16 is the highest, 0 is the beginning. So these are the flips of the LED array. Which location's flipping at what time and how. That's pretty cool. But now my curiosity is, why isn't my power flipping and my USB flipping? So then if this is an issue, I want to check to see if we ever enter power off, and also if we ever enter USB off, because it looks like it's never entering those locations. Might be a logical issue there. Nope. Wait, is it? Yeah, it is. But why isn't it flipping off? That should be an on and off flip here too. Oh, wait. Oh. I forgot to modify some things. True. Okay, hold on. I'm still using proximity in my USB LED. Proximity LED was over there, so I should be using USB. I believe that's the function. Yep, USB is the function. Or the method inside. And then I need to use power and power. So I forgot to swap the functions inside of the if statements, which caused the issue. Okay, LED USB. Takes 2 position arguments, but more were given. Oh, true. Okay, because there is no multiple USBs. Okay, so we don't even need a counter here. We just throw this like this. We don't even need a mod in the front here, because it doesn't even take a value. We just need true or false to turn that on or turn that off, because there's not many or multiple LEDs available to swap between. So we don't even need mods or zeros and ones. There we go. Getting there. Kinda. Power off is going. I'm wondering if these are messing stuff up. Let me comment these out now that we got them configured inside of our if statements. Okay, they did turn on. Oh, but I didn't force them off. That's the on, that's the off. There we go. Yeah, so copying and pasting can sometimes get a little ugh, because you got to keep track of what's changing, what's modifying, what needs to be adjusted. Okay, so there's all the LEDs we have blinking it up like a storm. Cool. Very cool. I wouldn't say it was a quick if-else statement logical process, but in the end, this is how you will control certain factors, certain parts with logical statements to accurately define what and where it's changing. So, that's good. And I guess we're done here, at least for now. Click this icon to the window. There's a sandbox mode. This will allow you to select different environments to explore. Cool. Yes, there it is. Now we're in the meats and potatoes. Now we are looking for messing with the thrusters. Max forward, max reverse. Now in the case of values, more than likely, we're not going to use directly 100% or 50%. We're not going to use the percentage symbol. Rather, we're going to always think of these 100% as decimal values. And math, back to math, any percentage value is an adjustment based on decimals. So if you say what's 100% of 10, the answer should be 10. The meaning of 100% is the whole. So if you look at that concept again and say, well, what's 1 times 10? Your answer should be the same. It's 10. There is a direct comparison to the fact that 1 is indeed 100%. When we multiply 1 by values, we're just saying, hey, give me the exact value, the whole value. The 1 times 10 equals 10. Now, if we break apart percentages into pieces smaller than 100, that's when we enter decimal territory. So half of 1, or 50%, would be 0.5, decimal-wise. So 0.5 of 10 is 5. This is the way we think when we're dealing with percentages. So we'll be inputting percentage values as decimals, my guess. Normally that's the situation. There's no way we're just going to be using percentages symbols unless it's really that user friendly, quote unquote. But there we go. Let's see what our goal is. Test the motors just to rotate the robot. I'm gonna keep the LEDs going because why the heck not? Why not have a a happy go crazy? Let me turn off the prints though. Happy go crazy LED bot. Unless we actually need to do something with those LEDs later. We'll figure that one out as it comes through. But now we want to turn on the motor. Rotates when the wheel turn. CodeBot rotates when the wheels turn with equal power in opposite directions. So turning means opposite rotation between two wheels. One's going 100%, the other one's going minus 100%. Since it doesn't have a type of, I guess, turning mechanism, we'll be using the rotation of the tires to make the turning for us. So I got an idea already. This is gonna be fun. Okay. Rotate your bot by turning the wheel in equal and opposite directions. So we need motors. Motors, soon your program won't end. They may loop forever. That's what I'm intending. So how about now we do motors? But it didn't give me details on the motors. Let's see, motor. Use the code check. All right, go into the API. Okay, there we go. So motor run left. Okay, so we're actually just using non-percentage, non-decimal values. 30 is 30% or 0.3. That's, I guess, pretty user-friendly. Now, I probably don't want to use it in the loop because I don't want to keep adjusting it. So I'm going to do it up here. Motor.run left 30. And then motors.run right minus 30. Let's see. Whoop. Nope. 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 Nothing. Maybe I do have to make it loop, huh? Oh, we gotta enable them. True. Okay. So motors dot enable. True. Yeah. There it is. There's our little CodeBot. LED crazy and moving now. Very cool. So that was pretty quick, right? So do the motors, pretty straightforward. We may have to guide it through different places. We may have to work around logical movements, when to stop, when to go. If there's objects in the way, we churn our motors in specific directions, move off to the side. There's a lot of logic that will become a part of our process here to accurately give it the ability to interact with the world around us. Especially in a dynamic situation, he could be going somewhere. Let's do that. Let's do it positive and positive. Is that forward? That's forward? Okay, I guess that's forward. Ooh, what's the fastest it goes? Speed to 100, Captain. That's so cute. Come back. Come back. I'm trying to catch up with you. Ah! Wish I could just follow this guy. And then we run into a wall. Well, this is where proximity sensors will come into play, right? Proximity sensors will detect that wall. Oh, and then churn. In our case, he just walked into it. But I guess this is going to be something he's going to be doing all day now. He's just going to continuously go until the battery runs out. But this is a simulation, so what battery? And he's going. How quickly they grow up. And now he hits a wall. See, even walls can stop this guy. Oh. He's doing something. Wait, I can't go all the way over there? Why not? Basketball. Where can I... Why can't I really move around this area? I lost him. I lost my boy! Oh, he's over there. Oh, he's stuck in a corner. And that's going to be the end of this. So, we've played with the LEDs. We've played with all the details. Relax, man. We're not running yet. Okay. Played with the LEDs. We played with all the details, at least the main components of our little CodeBot here. I'm excited. This is really cool. Finally getting to move the little guy around. Super cool. But this is basically how we're going to be interacting with the future, you guys. That's it. This is how the future is going to be. You got to know the API of every device, or maybe we have some sort of universal API. That's another case scenario. And if we have that knowledge on how to interact with hardware, I wonder if we're going to have like a basic user API that everyone knows, and then a special admin API. The future. Because users are defining, users are evolving. A user isn't what it used to be anymore. This app that we're given the ability to program this little device is calling us the user now. We used to interface as users with computers with a mouse and keyboard, which has icons and different images that makes interacting with a digital device much more easier, more intuitive. A visual GUI, graphical user interface, where we can identify things by colors, by shapes, by whatever. But now, users are evolving to this, to the ability to code Python on a hardware. This should make you think where the future is going. If we're doing this user evolution now, and it's only just begun to enter these robotics worlds, what are the jobs in the future going to look like? Because the users will maybe be the ones, if we're capable, and some of us do go into learning this detail, right? Some of us are here to learn this information. You've dropped in, you've left a couple of pieces of detail, you've asked questions, and we go over it. But some of you are interested, the others come in and leave. That's the problem. Those that come in and leave will be left behind. Because in the end, this is what a user will be in 5-10 years from now. We're going to have Optimuses and all of these robots where we ourselves can program them manually, because clicking and pointing only does so much. It limits our ability to really configure and customize things. Hard coding it from scratch gives us the ability to control things. You see how the LEDs were custom. The LEDs and the way that I created their pattern of blinking was unique. It wasn't anything this program wanted me to do, but I was the user and I defined how I wanted it to work. In the current definition, or maybe the post 5 years ago definition of a user, there would be one button that would give you the ability to make this blink one way. But what if you didn't like that one way? There was no button to change the way it blinked. This is an argument not specifically about the LEDs and what you want the LEDs to do, but this is an argument expanded from a simple idea of how one click and a button limits you from fully using the abilities of a device. You cannot program everything into some buttons and drop down menus, because the possibilities are endless. Just like mathematics, everyone can solve a problem in math their own unique way. Some may do it the same way, some may do it completely different ways, some may be like 90% the same as each other but slightly differ in some case scenarios. Because of that infinite path that we can take as developers on the code side of things, it gives us much more customizability. It gives us the ability to expand on the details in a much more broader sense of how we want it to work versus how they gave it to us to work as. Because those that programmed it for us, well, they programmed it in their own perspective. The way we program ours will be how we want it to work. So the user has evolved from, oh, let me point and click on a desktop. In 5-10 years, a user is going to be someone that uses code to define how their devices work. This is what these sessions are aiming to kind of prepare people for. Because, again, a user's changing. A user's evolving. It's not just an iPhone with icons anymore. We're going to have robots. We're going to have probably those little vacuum cleaner robots. All these kind of things that we would have to program for most optimal usage. We would program the vacuums on how our size, the size of our house is, what the most efficient place to clean most of the time is. The user will change from being a regular point and click boomer to someone that today is called a developer. So this skill is necessary. For the next 5-10 years, jobs will be gone, everyone's going to be fired, and AI is going to take over for most case scenarios. The only jobs available will be those that know how to control the AI and the robotics. That's my prediction. I'm seeing it happen in general sense. It's probably too early now because AI is still in its baby phases. But give it 5-10 years forward, We're going to be the ones programming the AI, or basically communicating with the AI with code. And this is going to be the format we do it in. It's not crazy difficult. And that's why these streams are here to essentially guide before that time happens. This is the second stream of this session. We started finally entering how to move our robot around. Before it was just logical adjustments to the LEDs and how we can control the LEDs to our liking, not to how they program them to be. And again, that's the big difference here. The big difference is we're going to be in control of the code in the future. Well, the user is going to be someone that uses code, not someone that clicks buttons on a screen. And having that endurance to learn this stuff now will benefit you in the future. So I'll end it there. We'll do more of these in the future. Make sure to like and subscribe if you do enjoy these sort of things. Maybe you don't enjoy it, but maybe you see that it will be a benefit. Push yourself to learn it. Whether it's from me or somebody else, learn it. I hope to be the best source for learning it on a human level, on a logical level. And I hope to be more of a attempt to tickle the curiosity of an individual and how things work, and then show you plainly, without all the complex communication vernaculars and vocabulary used in high-end classes, but break it down for simple terms. This is why I have a lot of students that have told me I can teach math to a monkey, because I was able to teach them. They saw their positioning in math is horrible, but they saw me able to teach them, and they said, wow, if you can teach me math, you could probably teach monkeys how to do math. Because I don't speak in words that are overcomplicated. I break it down into parts. I break it down into simple English. And it should be a case for not overlooking the way things work for the words people use. We can ignore the words. We can ignore all the extra complexities of how words are used. We're really focused on how things work. So, anyway, that was fun. That was nice. This was cool. So we'll continue with this forward in future sessions. But like and subscribe if you like this content. I do also mathematics stuff here and there to get the brain trained in the logical sense. We do need to practice logic in order to be better at it. Just like being an artist, it takes time to create art and practice art to make better art or more realistic art, or whatever art you desire to fine-tune it to be. Abstract, real, whatever. The point is, if we want to get good at something, we have to use it. We have to practice it. We have to continuously brain train our way towards it. We don't lift we don't lift 200-300 pounds by just letting a robot do it for us. And that's the problem today. We have robots doing almost everything for us. AI is thinking for us. Calculators are calculating for us. TV is creating images for us. We're not using imagination. We're not using calculation, and we're starting to let go of critical thinking. And we're giving that last piece of humanity to artificial intelligence. So let's not keep that ball rolling. Let's reverse the trend. Let's go back to thought. Let's go back to training our brain and prevent that from happening. That's my key. That's my goal, is to help people go back into the sense of how they work, focusing on where they want to put their energies into, and giving them options in the directions they may discover would be great for them, without even knowing that they were great in the first place. Overcoming obstacles is how you discover new things that you can do. And if you've always been having issues with math, then the obstacle is going to prevent you from seeing the path forward. So let's overcome those obstacles. Let's brain train together. Let's keep programming. Let's keep doing calculations and mathematics. And join me in the future. Hope you like this. Subscribe, support me. Go to my Patreon. If you want to support me further, go to my Patreon, Super Scholar Chris MIA. I'm streaming on all platforms now, attempting to do as many platforms as possible. X, Rumble, YouTube, Twitch, basically the main of the main. YouTube is acting up, getting a little crazy, so I'm adjusting with the times. Multi-streaming is the case that's modern nowadays. It's the best thing to do for your time If you're a streamer, multi-stream. Go to Rumble, set up an account. They give you the ability to multi-stream without having extra details in between. So follow me, support me. If you need help, you can hire me as a tutor, mathematics, anything from 5th grade, kindergarten, give or take. If you want me to teach a kindergartner, I can. And there are cases for ADHD and dyslexia and other forms of impediments that might be in the way. But if you want me to teach a kindergarten, it's like trying to use a chainsaw to like break a branch. Like you don't necessarily need that level of tutoring, but if you do need help teaching your child, I will be so happy to help. Get in communication with me. Ask me how I teach kids, how I make it entertaining, how I basically make their interests pop up, because I've seen what entertains kids now, and it's TikTok, unfortunately. Um, these kind of adjustments to the way we absorb information on a 15-second bite-sized gunk slop, it's harmful to us. But there is ways you can use that to your advantage by adjusting the way you teach as well. If you're teaching your kids, I would recommend not to let them enter this TikTok age until they're like a good developed brain. I want to say 16, 17, 18, but even then you're going to have your kid go on TikTok probably by 12, 11, 10. So the longer you can withhold them from these slop fests online, the better development your child will have up to that point. I teach, again, a lot of different students, everything from 6th, 7th graders all the way up to college, university, to professionals in their fields looking to understand how APIs work and programming. There's just so many different levels that I can work with. But if you just need advice on how to teach your young one, please do contact me on Patreon. Set yourself up with an account. You can become a free member, and you can email me through that communication factor. You can find me on Discord, also on my Patreon. As soon as you sign up for free, you get access to my Discord. It's even popping up on the chat right now. So join in on the Discord and have direct communication with me. My concern, it's just my concern, for those that are willing to learn, for those that are looking at the world right now and a little bit concerned about how it's progressing with everything taking our thoughts, AI taking our critical thinking, calculators taking our calculation, TVs and media taking our creativity. They don't let us read books and imagine anymore. Our imagination dies. They don't let us calculate and trial and error to learn. We just put some numbers in a device and it makes the numbers go boom. And now the last step is that they're taking our critical thinking. And our critical thinking is what defines us as individuals, the ability to think for ourselves. And you can see this in politics. And I believe this is what they're trying to do for the factor of this organization. But it just hurts us. It hurts us in so many ways. We should go back to the scholarly ways. We should think about the Renaissance. We should think about all the things that made us a humanity of potential, not a tool for those that wish to use us and then fire us later on a circle of constant struggle, financial. Oh, I can preach about this all day, y'all, but thanks for joining in. I hope you enjoyed it. Like and subscribe, and I'll see you in the next one, whether it's math or programming. I don't know. I don't have a schedule yet. The more people that start watching and asking questions, demanding specific types of topics, the more I lean towards those topics. So put your comments in the comment section below. What do you want to see next? Math, programming, Python, more of this, maybe some AI stuff, maybe some factoring, maybe some long division. Leave it down there. What is your weakness?